I wanted to talk a little bit about energy and hydrogen generation, and kind of sitting here thinking about the discussions that we've been having about energy in versus energy out. And one of the big arguments of the naysayers, they keep pounding me with the law of conservation of energy. You cannot get more out of a system than you put into it. Energy can neither be created nor destroyed, only altered form. Okay? And that's true, and I believe that 100%. I don't believe you can make something from nothing. And some of these devices that appear to be over unity aren't really over unity devices. What people don't understand, as you look at this video and you look behind me and around me, there's energy flowing all around me. The light that's being reflected into this camera is originated from the sun. There's radio waves from TV stations and radio stations passing all around me. There's sound from the road across the street. You can hear vehicles going back and forth. There's the energy, sound energy in my voice interacting with the camera. Okay, there's cosmic energy. There's electromagnetic. There's all kinds of electrical fields. I believe that we need to rethink how we view energy and the terminology that we use: over unity, free energy. Wind is free energy. Yes, you have to pay for a device to capture it, but it's there for the taking. Water falls out of the sky for free. 70% of the Earth's surface is covered with it. Okay, so we need to rethink our classical definitions, our terminology of what energy is, and what exactly classifies energy in and out of a system. The atomic bomb is a perfect example of something that may appear to be over unity. But what we're doing is we're harnessing an energy conversion, E equals mc squared. It's not over unity. There's mass being converted into energy. Nothing is gained or lost. There's a conversion taking place. Things like the Bendini wheel and the things that Tesla was experimenting with. These are devices that don't create energy from nothing. They extract energy from the environment. It's been demonstrated. If you were at the Alternative Energy Partnership conference last weekend, you would have seen some of Tesla's devices in action utilizing energy extracted from the environment. How? I'm not going to pretend to claim to know how that happens. Collapsing high voltage fields, I believe it creates an energy vacuum, draws energy. And do I have proof of that? No. Can I verify that? No. Am I master's or doctorate's level physicist? No. But I do know what I see, and I do know how to read, and I do know how to observe. Okay? So let's talk about HHO. Now that I've discussed a little bit about what I think over unity and free energy is. Don't forget about tides, solar. There's tons of free energy out there. People sailed around the world for free. You just got to build the boat and stock it full of food. The energy that you extract and use to convert to mechanical motion is free. But let's talk about HHO. Okay, number one, I have never claimed that HHO results in a net gain in energy. You cannot use HHO to get more energy out of a system than you put in. You do not get more energy out of a system that's utilizing HHO. It's impossible. It violates E equals mc squared. It violates the laws of thermodynamics. It violates the principles of the universe. It doesn't work that way. Where does the savings come from? It's all about combustion efficiency. The savings comes from improving on a terribly inefficient piece of junk design. The internal combustion reciprocating piston engine is a turd. You can put a blower on it, you can turboize it, you put headers on it, you can put fuel injection, you can sleeve it, you can change combustion head shape, you can change the pistons, you can redesign it. You're polishing a turd. The internal combustion engine, as we know it, without major modifications, is a turd. Look at the mighty engine. That's a way that you can take an existing technology and improve on it. Okay? My point is that 20% is nothing. That's not an extraordinary claim because of the incredible amount of energy wasted in the Otto cycle. It's all about time. I'm going to get technical with you, and I challenge anyone out there to refute my statements. Number one, the internal combustion engine is known to be at the best case scenario, 30% efficient. What does that mean? Only 30% of the fuel going in gets burned? No, that's not what I'm saying. What I mean is 70% of the BTU content contained in a volume of gasoline is wasted as heat energy transferred out of the system. Only at maximum 30% of that energy is actually used to do mechanical work. Proof? Why do we need a radiator? Okay, a vehicle going down the road burning gasoline is nothing but a heat generator. It leaves a gigantic heat trail behind it. Heat radiated off the engine block, heat due to friction in the internal components of the engine and drivetrain, heat transferred from the engine block into the coolant system to be wasted, blowing out through the radiator. By the way, the Peltier effect is a great way to convert heat into electrical energy. Look into it, guys. Okay, you can vastly increase the efficiency of your system. You might even be able to get away with removing your alternator altogether. Okay, to try to use the 70% of that heat that's wasted. Okay? What does HHO do? Well, first of all, let me explain. How is it that heat gets transferred? It's all about time. The longer a temperature difference exists between two surfaces, the more opportunity there is for heat transfer. In other words, the slower you make the combustion cycle, the longer the opportunity exists for the heat of that combustion to escape the containers of its environment and be transferred as heat instead of being used as explosive power to be converted into mechanical energy. Let's take the gasoline engine, for example. Everybody who knows anything about engines knows that in the ignition cycle, when you're compressing the air-fuel charge, getting it ready for the power stroke, you need to start the combustion burn before top dead center. Because gasoline is such a crappy fuel, it's the leftover of making diesel. Gasoline is crap. It's junk. It's one of the worst fuels out there. I can't believe that we fell for this scam for the past 100 years of using gasoline to power just about every aspect of our lives. It's the biggest scam. It's all about money and greed. I can't believe it, but it's true. It's so poor as a fuel that you have to start burning it before the piston is even at the top of the cycle. That's about slow burn speed. Inefficiency, that's what that's about. The combustion begins before the piston is even at top dead center, because if it doesn't, the gasoline air charge is still burning when the exhaust valve opens. And you're just burning gas out the exhaust. So you have to start the combustion process before you even reach top dead center so you can take advantage of the maximum explosive force after ignition. During that time, while the piston is still traveling up in the cylinder and the gas is burning, there's heat transfer taking place. Heat is being transferred from the combustion area into the cylinder walls and piston and head. It's wasted energy. Alright? So the maximum explosive force occurs right around top dead center. And then the explosive force does work against the top of the piston, and it's converted into rotation at the crankshaft and used to propel the vehicle. All the while, heat is being transferred from the combustion environment into surrounding environment and then removed through the cooling system. It's all wasted energy. 70% of it is wasted energy. Okay, and that is due to the extremely poor fuel quality that is being used inside the engine. So we've got a design that's an inherent turd, because you've got big masses of metal parts reciprocating hundreds of times every second, rattling themselves to pieces, and we're using a fuel that has a very poor flame speed, very poor burn quality. And because of that poor flame quality, a lot of the molecule chains of the fuel aren't completely broken down. Where do you think the emissions come from? Why is there a need for a catalytic converter? Why is there an emissions, a smog system? Why are there particulates in the exhaust? Guys, These are remnants of incomplete combustion processes. If 100% of the fuel was burned, we'd have virtually no emissions. Come on, guys. Think. Use your head. You don't have to be a physicist to understand this stuff. You just have to use your common sense. Okay? And your observations. If 100% of the fuel was combusted in the combustion chamber, there would be no emissions and there would be no need for an EPA when it comes to internal combustion engine regulation. Okay? So how does hydroxy play into this? Look at the burn color, the flame color of gasoline when you ignite the vapors. It's yellowish, orange, even red. Now you guys have seen in some of my videos and other videos, torch videos and whatnot posted by other people. What color is a true hydroxy flame? One that's not wet, one that's dry. White. Color is an indication of burn quality. The cooler the flame, the redder. The hotter the flame, the more white it is. Like it goes from red, orange, yellow, light blues, and dark blues, purple, and white. A dry hydroxy flame burns white, which means it's as close to perfect combustion as you can get. Hey, it's a perfect 2-to-1 ratio. The fuel versus oxidizer is in a perfect ratio. There's nothing left over. The product is heat, sound, and water. Okay? Now, when you mix even small amounts, yes, 1 part per 1,000 is enough to make a difference. The addition of that small amount of higher quality fuel does quite a few things. Number one, its faster flame front characteristics allow a more complete clean burn of the air-fuel mix inside the combustion chamber. As you begin adding larger and larger amounts of hydroxy, like with your average-sized car engine, anything above, say, 3 or 4 liters a minute, you need to adjust your timing closer to top dead center. This is a good thing because it means less time is being spent burning the fuel before it hits top dead center. It means that the maximum explosive force occurs sooner, which means there is less time for heat transfer to the surrounding environment. That is the key to increasing the efficiency. More of the energy generated during the combustion process is transferred into mechanical work to the top of the piston rather than heat transfer. It's all about time. The faster this combustion process can occur during the power stroke, the more efficient it's going to be. Okay? So there's two ways that this can happen. This can happen by improving on the fuel quality, and it can also happen with improving engine design. The hydroxy, because it has a faster flame front, allows for a more complete breakdown of the fuel molecules, the fuel chains. You know, if you study it, like it's a long, ugly thing, okay? And it needs to get fully broken down in order to combust completely, and it doesn't. That's why there are emissions. Hydroxy helps break down those molecule chains quicker, so that a more complete burn is observed. That's why your emissions go down. There is a real indication, a true indication. There is a decrease in emissions, and it's proof of the concepts that I'm sharing with you right now. I challenge you to prove my statements wrong. I challenge you to refute the fact that hydroxy helps reduce emissions. I challenge you to refute the fact that hydroxy improves the burn quality inside the internal combustion engine. You can't, because the proof is available, is witnessed right in front of every one of you. The mileage results, the emissions results, the horsepower results, the dyno results. It's all there. It's just a matter of getting you people to not to see it because you see it, to comprehend it, to understand that you have a right to be angry. You've been lied to for 100 years. This gasoline thing, it's one of the biggest scams in the world. And the United States is like one of the last countries to really endorse the use of gasoline. Everyone else has figured it out across the world that diesel is a superior fuel. The higher compression ratio, the lack of a need of a spark, is because diesel is a a better fuel. And a diesel engine illustrates one fact that I want to drive home right now. In order to get the maximum use out of any kind of a fuel, you have to build the engine to accommodate that fuel. In other words, you can't put gasoline in a diesel engine, and you can't put diesel in a gasoline engine. And we're running right now with a technical difficulty of trying to add hydroxy into a gasoline engine that's designed to run on gasoline. Okay? I mean, that's why we're running into timing issues. We're running into, engine management issues, because these engines weren't designed to run on these fuels, because they're a far superior fuel. But we are still able to extract gains by using these fuels, even in these inefficient turds that we're now using. I don't believe in the gasoline engine. Okay? I used to be a big freak of engine building and, getting into all this performance aspects. But since I've become educated and I've done my homework, I realize it's nothing but a turd. It's nothing but a waste of time, and it's part of a gigantic lie that is based on greed from just a few controlling people who have all the wealth. The little guys like me, doesn't seem like we matter, until all of a sudden we start using our heads and start thinking of new and improved ways on our own, with our own money and our own brains and resources, to beat the system, to come up with what we know is a better way. If you want the maximum efficiency out of hydroxy in an internal combustion engine, that engine must be redesigned to accommodate this faster burning, cooler burning fuel. Okay? But until then, until we come up with that, we've got to think of ways to use the existing technology. Speaking of existing technologies, I am a huge EV fan. Okay? And that's what DP Engineering is soon to be all about. EV conversions with on-board hydrogen-boosted gensets. Why use the internal combustion engine as a genset instead of a primary mode of propulsion? Because gasoline engines suck at loading. That is why they're so dirty and inefficient. They perform extremely poorly under low RPM loading and acceleration. Okay, it's a nightmare to keep the air-fuel ratio proper, to keep the emissions down. Okay, it's not the best use of the fuel and of the device. All right, so that's the thoughts of the day on energy and energy usage and hydroxy implementation into the internal combustion engine. It's a Smack's take on energy, and I believe I nailed it. This peer discussion, this peer review, is going to expose the truth. And there's a lot of people out there with a lot of money who don't want to see this conversation occurring, but there's no stopping it. We the people are going to take control. All right? And that's what I'm all about. Taking control and giving it back to the people, the way this country was originally set up and designed to operate. All right? So everyone out there, continue testing, continue exploring, get a real education. Find out the truth about things. Don't believe everything you read in books. Go build stuff, study stuff for yourself. Use your mind. Your mind, you don't give yourself enough credit. Every human being out there has the capability of insight. Okay, so just use the gifts that you were born with and educate yourself. All right? So here we are on a beautiful Vermont day, and in an environment that's full of energy and full of life. I just want to share with you my thoughts on how we can coexist with our environment instead of consuming it. Okay? Use the resources around you. Water is a resource that's around us. It's plentiful, and it is for free. And we're going to use it. Alright, so I want to say a little something about my measurement methods. So what we've done here, as far as filling up the gas tank, as far as how much volume, because I use the volume and distance method, I don't use OBD2 or anything like that. I use how many miles we drove and how many gallons of gas we went through. So what we have here is we fabricated a clear filler tube, okay? And right now, we're in the process of filling up the tank to do another test run.
but you can see it, okay? There's the level, and we're going to fill it up to here, okay? And then we're going to do our test run, and then we're going to fill it back up to here at that same exact line. And our odometer is correct, okay? It's verified, we've checked it, we've tested it, it's measuring the proper mileage. So, and not only that, we're using the same odometer for beginning and end of run. So the odometer is closest to the 1/10 of a mile. The answer is to have a clear and defined method for measuring volume. So go ahead and fill it right up to the line there, okay? This is how we do it. We're going to fill it right up to that black line. And then that's going to be the end of the argument. So here we go, filling it up. Filling it up. There we go, a bit more. Yeah, we're at the line, okay? Now, when we return and we refill this tube, we're going to refill it exactly to that point, and then we're going to look at our odometer. We're going to see how many miles we've driven on the test, and then we're going to look at our pump, and we're going to see how many gallons of gas we put into the nearest 1/10, and we're going to calculate our mileage. Okay, what you're looking at is a modification that we decided to perform on the Ranger because the engineers designed it so that the highest place on the tank is not the filler tube entrance. The highest place on the tank is on either side of it. So even when we filled the gas into the clear tube all the way to the top, there was still a gallon's worth of gas of trapped air in the tank, and all you had to do was shake the truck a little bit and the volume would go right down. It wasn't accurate at all. It was skewing our results really badly. So we didn't know how to overcome that without actually putting in a whole new tank that doesn't incorporate that problem. The filler tube is the highest spot, and we also know, we can know exactly how much we fill it with this graduated tube that I integrated into the tank. So not only can we visually see how many gallons we are consuming during the run, but we can also check our pump accuracy by checking the gauge, which was calibrated to the pump to make sure we're getting the right amount of volume reading. So we got a stock fuel pump. This is what we got. It's a 5-gallon Summit Racing cell, and I fabricated some brackets here, welded them onto the bed of the truck. So we know exactly how much fuel we're consuming without any doubt. There's no stupid design flaws in the tank that incorporate huge gallon-sized air pockets. This deal is pretty sweet here. Obviously, a lot of you guys aren't going to be doing this kind of modification on your own vehicles, but we're doing this modification because this is a test vehicle, this is a proof of concept, and we need an exact, precise method of measuring volume consumed. So the way we watch this is we know where we started. Okay, we're right at about 2 gallons right now, and we won't fill it all the way. We'll fill it to 3.5 gallons up here, and then we'll know exactly how much volume we started with, and then we'll measure it at the end. So go ahead and fill it. Keep going. A bit faster. Got a ways to go yet. And you can see, we can see the level climb. Okay, slow down, a little bit more, a little bit more. Stop. Right there, right at the 3.5 gallon mark. So that's how we're measuring our fuel consumption now. Like I said, that stock Ford fuel tank, it was impossible to get a good fuel measurement that way. Okay, here we have a 1997 Ford Ranger with a 2.3 liter, and this is the next test vehicle for the latest development in the SMAC design. Here we have 6-pack SMAC. These boosters are set up to draw between 10 and 11 amps, outputting almost 5 liters per minute. And you can see I have battery chargers on here that right now they're not functioning. We don't have a genset in the back of the truck yet, but in the future we're going to be powering this off a genset so that you can extend the range. But right now we're running right off the batteries, which are 125 amp hour marine cycle batteries, giving me about a 2-hour run time. You can see I've made a bubbler. No ECM adjustments, no O2 sensor adjustments. We're going to unplug the battery and reset the ECM. The vehicle hasn't been modified in any way, shape, or form except for these pimpin' rims and four-wheel disc brake conversion that the Spank did. This is the Spank's rig. We're going to go ahead and take a trip right now. We've filled up the tank to the top. His base mileage before we've done anything to it is 22.8 miles per gallon. So we're going to pump this thing up and go for a run and see what kind of mileage we get. Okay, we just got done with our test runs using six-pack Ranger Smack. Okay, and on our first run, we estimated we got our base mileage. We did a 61.3 mile round trip, same speed, same route, same time of day, same weight. We left the six-pack installed in the back, as you see here. We were doing, 65 on the interstate, same route. Okay, no, shifting it into neutral, constant tire pressure, everything constant, no games. This system will, on your average 45-minute commute back and forth to work, this will last the entire trip. You can have this in your vehicle fully charged in the morning, and it will take you all the way back home at 6 o'clock at night when you get back from work. Okay, and you plug it in at night, recharge it, and you do the same thing day after day, 5 days a week. Okay, on this truck, this 60-mile run right here, this is an average from where I live. Most of the people around here are driving 60 miles to get back and forth to work. So they're going to save $4 a day. Okay, that's a pack of what's a pack of cigarettes, man? Pack of cigarettes for like $4 or $5. That's a pack of smokes. Recognize, man. I mean, I don't believe in smoking, but I'm saying, who can't use an extra $4 a day? Who out there can't use an extra $4? Anybody? Hey, I'll take $4. I'll take it. Here, give it to me. Or save it and give it to yourself. Okay? You can build this. The plans are online. You've all seen, anybody that surfed my site, you guys know the plans for these. It's just 6 of them. That's all it is. Just take one of them and make 5 more. Get a couple of batteries. Build yourself a box. Okay? A couple of relays. Some wiring. And there you $4 a day. Whatever you invest in this, it's going to pay itself back over the lifetime of the vehicle. Guaranteed. And with the price of gas the way it is, yeah, okay, it dropped 50 cents. And now you guys think gas is cheap. I got news for you. $3.50 a gallon isn't cheap. And it's going to go back up. This thing is going to pay for itself. So you can't go wrong. And not only that, but it proves this stuff works. So there's going to be more to come. We're going to install a generator in the back of this thing, and we're going to keep, we got a big empty space in the back of this truck. We're going to put a genset in there, and we're going to take some long duration trips. This 88%, that's a conservative calculation on what we observed today. In reality, I believe it's more, but I have to go with the worst case scenario because that eliminates any kind of doubt. I mean, and here also, I just want to show you real quick. These are the this is the performance grid. These are bench tests on the 6-pack. Okay, that shows over a 1.5 to 2 hour time period. That's how I know we were hitting near that 6 liter per minute. If I start off cold at 90 amps, about halfway through, a little less than halfway through, we're hitting 6 liters per minute. Okay, we're hitting 100 amps. I actually checked halfway through the trip. We stopped. I checked. We were actually starting more than 90 amps. We were closer to 115 amps or so. We were running 130 amps about halfway through the trip. We just got a hose leading up to the intake. Okay, no FE, no O2 extender, no fuel remapping, no chips, no special programming, zero, nothing. All we did was reset the ECM, and now we've got 46 miles to a gallon out of this 1997 Ranger. Okay, let's talk a little bit about my latest design. I've dubbed the Gen 3. It's for the trucking applications. Try to help you guys save on fuel. Looking for a unit that runs really cool for long durations with a high hydroxy gas output. You need something that's going to run cool for hours and hours on end. And so this is the design that I've been working on. And I explained that this basically was inspired by the 6-pack. As you can see now, the 6-pack is gone, and we now have in its place the new Gen 3 design. So I'm using 6x6 plates. The case itself is about 13 inches long. I think it's 10 inches wide and about 10 inches high. But for now, This is what we're prototyping. Okay, still got the battery packs in here, the 225 amp hour deep cycle batteries that cost 40 cents. Check my other videos. 40 cents to recharge these after they're fully depleted. 40 cents.
It's called a kilowatt. It's basically a watt hour meter, and it enables the user to measure the amount of kilowatt hours consumed by any electrical device that it's connected to. And in knowing how much you pay per kilowatt hour from your electric bill, you can calculate exactly how much that device consumes in any given time period. So there's been some discussion about the cost of charging the batteries on the 6-pack SMAC not being worth the savings that you get on the road. You know, some people are saying, oh, it costs you $5, $10 to recharge these batteries every time. I know this isn't true. I know it just by gut intuition, understanding how batteries work and what it costs to run devices. I knew that wasn't true, but I had no way of really proving it until I got this device. What I've basically done here is I've depleted the batteries down with another test run that we did. So I plugged it in last night. It has been plugged in for, it's a really handy little deal, it's been plugged in for 19.41 hours, okay? We've been charging it at 119 volts, and currently, to prove that it's pretty much fully charged, we're only seeing a 0.47 amp draw, okay, in current. So when I first plugged this guy in to my awesome little chargers here, okay, initially they each run 10 amps apiece. So a 20 amp total current draw to recharge these batteries when first plugging in, and now we're down to almost nothing, less than a half an amp. The computation is pretty simple, you guys. So 2.69 kilowatt hours, I'm paying about 15 cents a kilowatt hour to my power company. That's 40 cents. 40 cents. Okay, I saved $4 on my run with using the 6-pack, and it cost me 40 cents to recharge those batteries overnight. Hey, it's a net savings of $3.60. Listen, electrical power is one of the most efficient power sources that you can utilize, and that's the idea of what I call EV assist. The only way to get better is to use wind or solar to charge these batteries. I mean, because the grid is going to be your most efficient source for right now. And guess what? The grid is something that you have access. Almost, 99% of American population has access to electrical grid power. So use that grid power. This is a much cleaner, affordable, and more socially responsible power source. So use the grid when you can, okay? And even better yet, use wind, solar. The answer is not drilling, because energy is the #1 problem on this planet, okay? So drilling is not the answer. The answer is to harness more of our natural resources, natural being the resources that are right here on the surface of the planet, okay? Just take a look at Iceland and their use of geothermal power to create hydrogen. 2-gauge cabling from the 2 iota battery chargers, okay? So no overheating of any of the connections. They're all soldered. Everything, lock washers on the bolts. Same thing going into the cell. And notice that all the electrical connections are below the water line on this cell. Okay, as you see, I've got a panel here bolted down with rubber gasket material that I've got this gigantium bubbler here that holds about 1 liter of water, and also in the front of the vehicle there will be another bubbler. Okay, so with the new tank modification to ensure proper measurement readings, and the new series/parallel plate combination design, the Gen 3. We had it set at about 30 amps, a little over 30 amps, and of course throughout the duration of the 50-mile trip the amps did drop slightly. It went from, say, I think it was 35 amps down to about 28 amps towards the end of the run. Okay, but a pretty solid, consistent current draw throughout the 50-mile trip. So we used 1.78 gallons of gas during that 50 miles. It came out to about 27.6 miles per gallon. At 60 amps, we measured 5.8 liters per minute. We performed
the ECM reset procedure. There's no FE device on here at all, no other modifications other than the fuel tank. We're not too confident in the ECM reset procedure working for this particular application, but we are still seeing a solid increase across the board. Definitely not our 88% increase that we first recorded during one of our first runs. And our base mileage is 24.6 miles per gallon, so now we're up to 27.6 with 3 liters per minute. And we, like I said, we have not used an FE device. The computer the ECM reset procedure just is not really responding the way we were hoping that it would. And a lot of the other guys out there doing ECM resets have noticed the same thing. They're not really seeing that much of an increase, although they are seeing some increases. 50 miles, 1.78 gallons.